Okay, this is free response question 1. For this free response question, you are always going to be given an equation that'll always be called g of x. And you're also going to be given either a graph or a table. Obviously, in this case, we have a graph. The very first thing I would recommend you do on this problem is go to Desmos and type in our equation. So I'm going to go over to Desmos and I'm going to type in g of x equals, when you have a fraction, if you just hit the division sign right away or type the / on your computer, that'll make the fraction for you. You can also do it with parentheses after the fact if you forget. So we've got our equation typed in. We can zoom in and out. In general, I would recommend zoom out. Just make sure the graph doesn't do anything crazy. You can always get back by hitting the home button in the top right. So we've got our graph. Now let's go ahead and start this first problem. So it says h of x is g of f of x. It shows both different ways of doing function composition. Find the value of h of 2. So h of 2 is g of f of 2. The first thing we have to do is find f of 2. So I'm going to look, where is x equal to 2? And then where's my graph right there? So f of 2 is equal to -2. That makes g of f of 2 g of -2, just coming from right over there. To find g of -2, we're going to go to Desmos. On a new line, just type g of -2, and it will give you your answer, in this case, -1.2. For AP Pre-Calc, always give 3 decimal places. You can truncate or you can round on the 3rd decimal place. If you're not comfortable rounding, I'd recommend just write whatever Desmos says, the first 3 decimals. Number 2, this can be a variety of things, but for this one, it is find all real zeros of f. So 0 for f is our graph. That is where it crosses 0. So we can pretty clearly see there are 2 zeros for f. That is going to be at x equals 1 and x equals 5. You could also write this as x equals 1, 5. That would also be fine. Okay, B1. Find all real values of x as decimal approximations for which g of x is 2.3. This is also a fairly easy question. So g of x equals 2.3. We're going to do that using Desmos. So g of x, that's our output. That's our y. So I'm going to say y equals 2.3. And when I do that, we'll see there's a line that pops up on the screen. If we click on the intersection of the line and our graph, that will give us our answer. In this case, this is 0.5272. If you truncated and you just said 0.527, that's fine. In this case, if you round, you get the same thing. So this is x equals 0.527. One thing I would recommend doing, zoom out. Sometimes there are multiple answers, and if you're in this default view, you might only see one. But in this case, just one answer. Okay, B2. Determine the end behavior of g as x increases without bound. We're going to do this with a limit. So this is the limit as x goes to something of g of x equals. And we need to fill out what is x going to and what does g of x go to when x goes there. So it says x increases without bound. Because that says increases without bound, that means x is going to infinity. If it said decreases, that's negative infinity. The limit of g of x as x increases without bound, we're going to go over to our graph and we're going to look. You can ignore the green, that was a previous question. As I go to infinity, what happens to my y value? So the options here are going up, going down, or flattening out. In this case, we're pretty clearly flattening out, and we're getting closer and closer and closer to 0. So the limit here is 0 because as we go to infinity, as we go to the right for x, our graph flattens out to 0. C1, does the function f have an inverse function? So when we're looking for an inverse function, or whether a function is invertible, you are looking, does every input have a unique output? So if I pick a point, let's say this one right here, 0, 7. This has to be the only spot on the graph that I have 7 as an output. But if I look, straight over, there are clearly 2 other points on this graph with the same y, different x's and the same y. So in this case, no. Does the function have an inverse function? It doesn't. You can write more, but if you just say no, that is enough. C2 is always a justification problem. Give a reason for your answer based on properties of the function f. Refer to points on the graph of f in your reasoning. So properties of the function f, we want to say no. I'm going to change how I'm wording this. There are multiple inputs that produce the same output. The key thing, refer to points on the graph. We need to say, for example, f of 0 equals f of 8 equals 7. And this is just saying 0, 7 and 8, 7 are both on the graph. They have different inputs, but the same output value of 7. There are a bunch of different ways you can word this for C2. I think when I showed you this earlier in the year, I phrased it differently. We did it with points, but I think this way is a little faster to write. As long as you give specific examples from the graph, you are fine.